Betelgeuse is one of the most recognizable stars in the night sky. Located in the shoulder of the Orion constellation, it's a red supergiant nearing the final stages of its life. Its size is immense. If placed at the center of our solar system, it would extend beyond the orbit of Mars. But recently, Betelgeuse has been behaving in ways that challenge everything scientists thought they understood about stars of this kind. It's dimming in unpredictable patterns. It rotates faster than expected, and some of its movements and light variations suggest that an unseen force may be acting on it. This has led to a growing theory in the scientific community. Betelgeuse might not be alone. It may be part of a binary system, sharing space with an elusive, dimmer companion star that's difficult to detect, but possibly responsible for much of Betelgeuse's strange behavior. In this episode, we'll examine the evidence behind this hypothesis, walk through the key discoveries of the past few years, and look ahead to the technologies that may soon solve one of astronomy's most intriguing mysteries. In late 2019, astronomers noticed something unusual. Betelgeuse, typically one of the brightest stars in the sky, was fading. And fast. Over the span of a few months, its brightness dropped by almost 40%. For a star so massive and close, this kind of dimming was unprecedented. Some scientists speculated that the star was entering its final phase and could be on the verge of going supernova. Others suggested the event might be caused by more mundane phenomena like surface cooling or dust. Eventually, observations from the Very Large Telescope in Chile and the Hubble Space Telescope provided a likely explanation. Betelgeuse had ejected a large cloud of dust, which temporarily obscured our view from Earth. This massive outburst likely came from a patch of the star's surface that expelled stellar material, which then cooled and formed a dust cloud. But while the dust accounted for the dimming, it didn't explain why the ejection occurred in the first place. For such a large event, astronomers expected to find an external trigger. Betelgeuse is a variable star. Its brightness naturally fluctuates as internal convection cycles push and pull on its outer layers. Most of these variations are irregular or occur on timescales of several hundred days, but scientists studying historical light curves of Betelgeuse noticed something else, something harder to explain. A long period brightness variation repeating roughly every 2,100 days, almost 6 years. This wasn't a one-off. It had been observed repeatedly over decades of data, and it was too regular to be the result of random internal fluctuations. This led to a striking hypothesis. What if Betelgeuse was being influenced by something external? Perhaps another object, something with enough mass to cause periodic shifts in the star's outer envelope, but dim enough to have avoided direct detection. The idea of a hidden stellar companion began to take shape. To investigate the companion theory, astronomers designed a targeted campaign using the Hubble Space Telescope. The goal was to detect light from a possible companion star, assuming it was emitting in the ultraviolet part of the spectrum. If Betelgeuse's hypothetical partner were a young, hot, low-mass star, it might emit strongly in the far UV. Using Hubble's STIS spectrograph, a team led by Jared Goldberg conducted observations at a point in the supposed orbit where the companion would be most likely to appear outside the dust envelope. No companion was detected, but that doesn't mean the theory was disproven. Betelgeuse itself is incredibly bright, and it's surrounded by clouds of gas and dust that scatter light. The contrast between the supergiant and any nearby object makes direct imaging extremely difficult. Even with Hubble's resolution, the companion, if it exists, might simply be too dim or hidden in the surrounding material. Astronomers were left with circumstantial evidence, but no definitive visual confirmation. Red supergiants like Betelgeuse are in the late stages of stellar evolution. By this point, they've expanded to enormous sizes and should be rotating very slowly due to conservation of angular momentum. But Betelgeuse rotates faster than models predict, up to 15 kilometers per second at its equator. That may not sound fast by Earth standards, but for a star this massive, it's well above expectations. So what could be keeping it spinning? One explanation points to gravitational interaction with a nearby object. Just as the moon causes tides on Earth, a nearby stellar companion could exert tidal forces on Betelgeuse. These forces would transfer angular momentum, helping the star maintain a higher rotation speed. Models that include such a companion match the observed rotation much more closely than those that don't. There's also a possibility that Betelgeuse absorbed a smaller star in the past. Some simulations suggest that a red supergiant can cannibalize a lower mass companion, leading to a temporary increase in mass and a spike in rotational speed. This could explain why Betelgeuse is more massive and spins faster than expected, but that scenario would be a one-time event. It doesn't account for the ongoing 2,100-day cycle or the repeating surface disruptions and dust ejections still being observed. A surviving companion on a longer orbit provides a better fit. It could be interacting with Betelgeuse periodically, perhaps every 6 years, and triggering the disturbances we now observe from Earth. This theory also aligns with a broader trend in stellar evolution. Most massive stars form as part of binary or even multiple star systems. A truly isolated red supergiant would be an exception, not the norm. Understanding whether Betelgeuse has a companion star isn't just a curiosity, it has real implications for astrophysics. First, it could help explain how massive stars lose mass before going supernova. Betelgeuse is surrounded by large amounts of gas and dust, some of which were likely ejected in recent decades. A nearby object might be shaping or even triggering these ejections. Second, a binary system would change how scientists model the timeline to Betelgeuse's eventual explosion. If interactions with a companion influence how the star sheds its outer layers, they also affect the timing and intensity of the eventual supernova. Finally, Betelgeuse offers a rare chance to study such interactions in real time. It's close, bright, and constantly monitored. What scientists learn here can help refine models for how binary interactions influence everything from mass loss to stellar collapse across the universe. To confirm the companion theory, astronomers are now relying on next-generation instruments. The James Webb Space Telescope, JWST, launched in late 2021, has the sensitivity and resolution to peer through dust in the mid-infrared spectrum. It's ideally suited to detect the heat signature of a smaller companion if one exists. Observations targeting Betelgeuse are already underway or scheduled in the coming years. Ground-based observatories like the European Extremely Large Telescope, ELT, expected to begin operations later this decade, will provide even sharper imaging capabilities. Using adaptive optics, the ELT might be able to resolve separate objects within the dense environment around Betelgeuse. Meanwhile, smaller telescopes on Earth continue to monitor the star's brightness and spectrum on a nightly basis. These observations help astronomers detect new patterns in real time and refine predictions about the timing of future events, like another possible dimming cycle in the next few years. All of this is part of a global effort to understand what's really going on in this iconic star system. Betelgeuse is not behaving like a typical red supergiant. Its unpredictable dimming, unusual rotation, and long-term light fluctuations suggest that something more complex is at play. While dust clouds and surface activity can explain parts of the story, they leave key questions unanswered. The idea that Betelgeuse has a hidden companion, something orbiting every 6 years, stirring its envelope and influencing its evolution, is now one of the leading theories. If that companion exists, it could help scientists answer long-standing questions about how massive stars live, die, and interact with their environments. And while Betelgeuse may not explode tomorrow, every new observation brings us one step closer to understanding how and when that final event will occur. For now, Betelgeuse remains one of the most watched and studied stars in the sky, not because of what we see, but because of what might still be hidden. If you enjoyed this video and want to see more like it, consider subscribing, hitting the like button, and sharing it with someone who might enjoy it too. Thank you for watching, and see you in the next video.